Good morning, everyone. Let me start with a simple question. What is chemistry? Chemistry is the science of matter, what everything is made of, how it is structured, and how it changes. If you can touch it, taste it, breathe it, or see it, chemistry is involved. Your phone, the air around you, the food you eat, the medicine you take, the clothes you wear, and even your own body, all of it is chemistry. In the next 20 minutes, we're going to explore what matter is made of, how atoms bond and react, the main branches of chemistry, and why chemistry matters in everyday life. By the end, you'll see that chemistry isn't just a school subject, it's the language of the material world. Everything around us is made of matter, and matter is made of atoms. Atoms are incredibly small. Millions of them could fit across the width of a single human hair. Yet these tiny particles build everything in the universe, from stars and planets to cells and living organisms. Each atom has three main parts. At the center is the nucleus, which contains protons and neutrons. Protons carry a positive charge, neutrons have no charge at all. Moving around the nucleus are electrons, which carry a negative charge and exist in regions of motion rather than fixed paths. The number of protons in an atom defines the element. For example, an atom with 1 proton is hydrogen, an atom with 6 protons is carbon, an atom with 8 protons is oxygen. These elements and many more are organized in the periodic table, a powerful tool that acts like chemistry's map of the universe. The periodic table organizes all known elements according to their properties. The horizontal rows are called periods. The vertical columns are called groups. Elements in the same group tend to behave in similar ways because they have similar electron structures. For example, elements in group 1, such as sodium and potassium, are highly reactive metals. They react strongly with water and must be stored carefully. On the other hand, elements in group 18 are known as noble gases. They are extremely stable and rarely react with other elements. Some elements are metals, some are nonmetals, and others fall in between as metalloids. The key idea here is stability. Atoms tend to react because they want to become more stable, and this desire for stability leads directly to chemical bonding. Atoms rarely exist alone. They form bonds with other atoms to create molecules and compounds. There are 3 main types of chemical bonds. The first is the ionic bond. In an ionic bond, one atom gives up 1 or more electrons and another atom accepts them. This creates charged particles called ions, which attract each other. A classic example is sodium chloride or table salt. The second type is the covalent bond. Here, atoms share electrons instead of transferring them. Water is a perfect example. Each oxygen atom shares electrons with 2 hydrogen atoms to form a stable molecule. The third type is metallic bonding. In metals, electrons are not tied to individual atoms. Instead, they move freely through the structure, which is why metals conduct electricity and heat so well. Chemical bonding explains why water is a liquid, salt is a solid, and oxygen is a gas. In chemistry, structure determines properties. This is one of the most important ideas in the entire field. A chemical reaction occurs when chemical bonds break and new bonds form. The substances you start with are called reactants. The substances you end with are called products. For example, when hydrogen reacts with oxygen, water is formed. Chemical reactions power nearly everything around us. They allow us to cook food, digest nutrients, generate electricity in batteries, create fire, and even breathe. One of the most important principles in chemistry is the law of conservation of mass. This law states that matter is neither created nor destroyed in a chemical reaction. Atoms are simply rearranged into new combinations. Chemical reactions can happen quickly or slowly. They can release energy or absorb energy. They can be carefully controlled or extremely explosive. Chemistry allows us to understand these reactions and use them safely and effectively. Chemistry is a vast field, so it is divided into several major branches. Organic chemistry focuses on carbon-based compounds. This includes plastics, fuels, medicines, and the molecules of life, like DNA. Inorganic chemistry deals with all other elements and compounds, including metals, minerals, and salts. Physical chemistry studies energy, reaction rates, and the physical principles that govern chemical systems. Analytical chemistry focuses on identifying substances and measuring how much of each substance is present. It is essential in laboratories, forensics, environmental testing, and quality control. Biochemistry is the chemistry of living organisms. It explores enzymes, proteins, metabolism, and the chemical reactions that make life possible. Together, these branches explain how the material world works, from the smallest cells to entire cities. Chemistry is not confined to laboratories. It is part of everyday life. In medicine, chemistry allows us to create vaccines, antibiotics, and painkillers. In food, chemistry controls flavors, preservatives, and fermentation. In the environment, chemistry helps us understand air quality, purify water, and study climate change. In technology, chemistry makes batteries, screens, semiconductors, and solar panels possible. In health and hygiene, chemistry is behind soaps, toothpaste, nutrition, and clean water. Even our emotions are connected to chemistry. Hormones and neurotransmitters are chemical messengers that influence how we feel, think, and act. When you understand chemistry, you begin to understand why things work, not just that they do. Chemistry helps us create new materials, solve environmental challenges, improve health and energy systems, and understand life itself. It connects physics and biology, linking the laws of the universe with the processes of living organisms. Chemistry explains both the ordinary and the extraordinary. So the next time you drink a glass of water, cook a meal, or take a breath, remember this: you are witnessing chemistry in action. Thank you.